All right. So this is Math 123, Lesson 51A. I'm Jeremy Nally. And throughout this video, I'll be working through examples, and I want you to pause the video before you see me start working the example to see what you can do. You'll get the most out of the video that way. If you just, sit back and watch, it's not going to do as much for you. All right, here we go. Okay, write the ratio. Number one, from 1969 through 1977, four of the teams in Major League Baseball made the playoffs each year, while 20 did not. Now 10 make the playoffs and 20 do not. Write the ratio of teams making the playoffs to the total number of teams in 1969. Write the ratio in fractional form, then reduce the fraction if you can. And then question B is write the ratio of teams making the playoffs to the total number of teams today. Write the ratio in fractional form, then reduce the fraction if you can. Okay. So for part A, it says ratio of teams making the playoffs to the total. So we want making playoffs over total. Now, it says in that era, four teams made the playoffs, and it said 20 did not. So they gave us, making playoffs to not, and then they said that was 4 over 20. But now we want making playoffs to total. So making playoffs, we know, well, that's going to be 4. Now, let's think about this for a minute. So if you have four teams who made the playoffs and 20 didn't, how many total teams do we have? So that means we have 20 plus 4. So the ratio becomes 4 over 24, and we can reduce that to 1/6. Okay. So now for teams today, so making playoffs to not, that's what they told us. They said 10 make the playoffs and 20 don't, but we want making playoffs to total. So what are we going to do? Well, to figure out the total, we just add the 20 and the 10. So now it's 10 over 30. So the ratio reduces to 1/3. Okay. In May 2019, 25 of the 100 US senators were women. Write and reduce the ratio of female senators to male senators. Interpret what this ratio means. So they just gave us 25 over 100. So now if we look at this, that's going to be women to total. But now they're asking for the ratio female to male senators. Well, they didn't tell us how many male senators. Well, to figure out the number of male senators, I can just take 100 minus 25. So now I have 25 over 75. So now 25 to 75 reduces to 1/3. Okay, so there's the reduced ratio of female senators to male senators. Now, to interpret what this means, just think about what that's saying. So we could say for every, oops, one female senator, there are three male. I'll just squeeze it in over here. Senators. Or you could say for every three male senators, there's one female senator. You can phrase that however you like, as long as it makes sense. Okay, a sub shop advertises a new 18-inch sandwich. Not to be outdone, a rival chain comes out with a 2-foot long sandwich. Why is it deceiving to write the ratio of the rival chain sub to the sub shop sub as 2 over 18? Well, let's take a look at that. So that's 2 feet over 18 inches. So the units don't match. I realize that's not a great sentence. I guess I could put the units don't match, period. There we go. That's a complete sentence. All right. How should I write the ratio in order to make it meaningful as a size comparison? Well, uh, 2 feet. Well, that's 24 inches. So now if I have 24 inches to 18 inches, we can see that we have like units. So we get 24 over 18, and we can reduce that. So they each have a 6 in there. So then that's going to be 4/3. Okay. Now, well, what if I, instead of converting the feet to inches, what if I took that 18 inches and I converted it to feet instead? So I have 1.5 feet. So then that would be 2 feet over 1.5 feet. Well, the feet cancel out. So now I have 2 to 1.5. Well, how do I fix that? So how do I fix that 1.5? Well, if I multiply the 1.5 times 2, that will turn into a 3. But if I do that to the bottom, I have to do it to the top as well. So then I end up with 4/3. That one was it's a little bit trickier to do that way, but this is just an alternative path. It's probably the harder path, but it still gives the correct answer. All right. A Gallup poll conducted in 2017 indicated that 12 out of 100 Americans did not have health insurance. Write the ratio of those who have health insurance to those who do not. So, so they gave us did not to total was 12 over 100. So they want the half to the did not have. So staring at that, let's just make sure I have that. Yeah. So we already know the did not is 12. And then to get to how many have it, we just take that 12 out of that 100 total. So I have 88 over 12. Okay. And then let's see. That's 4 times 22 over 4 times 3. So I have 22 over 3. And then if I wanted to interpret that, I would say for every 22 Americans who have health insurance, there were 3 Americans who did not have health insurance. Okay. John's lawnmower uses 3 gallons of gas every 2 hours. Complete the table below showing the number of gallons and the number of hours. So we have 3 gallons over 2 hours. Now, if I just divide those numbers, I get 1.5 gallons per 1 hour. So right here, I can fill in the 1.5. And then all you have to do for the rest of these is you can just scale it up. So if that's 6 hours, so I multiply that 3 times 2, and then I'd multiply the 2 times 2, and that would give me 6 gallons in 4 hours. And then same thing, 3 gallons, 2 hours. So now if I'm at 6 hours, then I was multiplying that bottom one by 3. So I got to do the same thing to the top. So then that's going to be 9 gallons in 6 hours. So then that gets a 9 there. Was this the only way to do that? Absolutely not. This is just a convenient way where I can just write some stuff down and show you some kind of reasoning that got us there. Okay. Unit price is a ratio of costs per one individual item. So Kroger lists these prices for Reese's peanut butter cups. Share size is 10.5 ounces and costs $4.19. Family size is 17.6 ounces and costs $6.79. Party size is 35.6 ounces and costs $12.99. What is the cost per ounce for each bag? And then the last part is what is the better buy? Okay. So for the share, um, so you're taking the money over either the quantity or the size. So the weight. So I'm going to take that $4.19 divided by 10.5 ounces. And I get approximately, oops, 40 cents per ounce. For the family, I'm going to take the $6.79 divided by the 17.6 ounces. And I get approximately 39 cents per ounce. And then for the party, I'm taking the $12.99 over the 35.6 ounces. And I get about 36 cents per ounce. Okay, so that's the unit price for each one of those. Which option's the better buy? The one with the lowest unit price, which is the party size. Okay. This is one of the most practical things that we're going to talk about this week. I do this all the time. So if you haven't been doing this with your life, you should start. It could save you a little bit of money or a lot sometimes. Okay. Uh, so now this one's kind of flipping the idea upside down, literally. If 16 ounces of sesame seeds cost $4.19, how many ounces can you get for $1? So it's kind of like the flipped unit price. So instead, we're going to do quantity over money, whereas back here, so unit price is the money over the quantity. Okay, so why are we doing it the other way around? This is kind of like one of those things. Well, I only have $1. How many sesame seeds can I get? Is kind of what this problem's doing. So 16 ounces over $4.19. So when we put the money on the bottom like that, what's going to happen is when we reduce this, it's going to be whatever is on top in ounces over $1. So I end up getting, so to the nearest tenth, 3.8 ounces, and the unit on the bottom is dollars, right? So if I rewrite that a little bit better, you can think of it as 3.8 ounces over $1. So for $1, you get 3.8 ounces. Okay. Renting a bicycle for 4 hours costs $30. How much would it cost to rent the bicycle for 1 hour? Oh, that's just a regular unit price problem. So we put the money on top. So the quantity this time is hours. So that's going to be $7.50 per hour. So you could think of it as $7.50 over 1 hour. So at the end of the day, for $7.50, you get 1 hour of bicycle rental. Okay. Um, I know you might feel silly, but I want you to say this. Per capita means per person. So, and then here's what I really want you to say. Per capita means divide by the population. And more specifically, humans. So if it's dogs versus humans and you're trying to figure out dogs per capita, you take the number of dogs divided by the number of people. Okay. Okay. So imagine, so this is number 9. Imagine 5 people go out for a meal. The bill is $115. If they go Dutch and split the bill equally, how much would each pay? This is a per capita value. So you go out for a meal and like 4 of you get the soup and salad, and then like one of you orders like the most expensive steak on the menu, and then that's the person who wants to go Dutch, like guaranteed. You probably know that person, and you dread them asking to go out to eat because you know they're going to pull this crap. So, I can't fix that, but you can always say no. It's okay. Don't let them win. All right, let's do the problem. Let's say you do go Dutch. All right, so there's 5 people. That's like the population. So you would take the $115 divided by the 5 people. So we get $23 per person. Okay. Driving through Fort Wayne, it seems like there's a Walgreens pharmacy on almost every corner. However, CVS pharmacies seem to be in many smaller towns, making it appear that Walgreens focuses on large cities and CVS tries to be accessible to more people. There are 188 Walgreens locations and 305 CVS locations in Indiana. The population of Indiana is 6.8 million. What is the per capita rate for each store? Okay. So let's take a look here. So let's do Walgreens. So that's 188. And per capita means we divide by the population. So 6.8 million. Oh, no. Oh, there we are. So now million is 10 to the 6th power. So I can quickly write 6.8 million as 6.8 times 10 to the 6th. Now, if you want to write it out the long way and go 6, comma 8, 0, 0, 0, 0, 0, that's okay. It didn't say anything about using scientific notation. I'm using it for efficiency's sake. Okay, so I take and divide. Okay. So when I divide that, my calculator just happened to spit out scientific notation. It says round to 7 decimal places. So 0.7 So I'm just going to unravel that in my head a bit. Two, seven, six. Let me count that. So 1, 2, 3, 4, 5. All right, I'm happy with that. Okay, CVS's. So that's 305, and it's the same population. It's population of Indiana, or at least at some point in time, the population of Indiana. So, oops, there we go. So I'm getting 0.00004, excuse me, 449. Okay, so this is Walgreens per person. This is CVS is per person. So now if I wanted to say this properly, let's see. Tenths, hundredths, thousandths, 10,000ths, 100,000ths, millions, 10 millions. I would say there are 276 10 millions of a Walgreens per person in Indiana. There are 449 10 millions of a CVS per person in Indiana. Those are kind of unreasonable to say, right? You don't hear people on the news talking like that. So now, uh, what we're going to look at next is how do we scale those to make them sound more reasonable. So looking at number 10, it's hard to apply meaning to these numbers. Use the answer to number 10. How many Walgreens locations are there for every 100,000 people in Indiana? So think about my percent trick. Right? What do we do? So we multiply by 100, right? This is the same idea. We're going to multiply by the thing. So in this case, we're going to multiply by 100,000. So for the Walgreens, we're just taking that 0 point, and I really hate writing this out the long way. I wish I was writing it in scientific notation. Okay, so um, I can at least multiply it in my head using ideas from scientific notation. So I get 2.76 Walgreens. And now this, since it's been scaled, it's per 100,000 people. Okay. Okay. Using the answer to number 10, how many CVS locations are there for every 1 million people in Indiana? Um, so same idea. We're going to multiply by 1 million this time. So we're going to take that 0.0000449 and multiply by 1 million. So I get 44.9 CVSs per 1 million people. Okay, there are 172 gas stations in Fort Wayne, and Fort Wayne has a population of 343,000 as of the time this question was written. Uh, how many gas stations are there for every 10,000 people? So, well, let's set up the per capita. So the per capita is 172 divided by the population, divided by the population, divide by the population. Now, we can just kind of speed up the whole process. So what were we going to do when we were done? We were going to just multiply that by 10,000, right? So you can do it bit by bit if you want, or you could do it all in one go. Either way, you should be trying this on your own. If something in this video is not making sense, have you tried doing it? Or are you just trying to make sense of it by watching it? Make sure you're actually writing stuff down if you're watching this. You'll get more out of it. So to the nearest whole number, I get 5 gas stations per 10,000 people. All right, that's the notes for 5-1. I'll do some different examples in class. We'll have some fun. Um, it'll be hilarious, I hope. But either way, I know I'll have fun. See you in class.